Hello everyone, I am Mantra aka Mantra 7, and in this video we are going to explain you the solution for Codeforces Round 797 Division 3. I was able to solve 6 problems in this round, so I will explain solution for that, and then Aditya C will explain the solution for G problem. So let's get into it. The first problem is print a pedestal. So what they want is we have to we have blocks given and we have to make 3 towers of them such that middle tower is the highest, then the left one is the second highest, and right one is the third highest. And they should be like strictly higher than each other, equal to won't work. And for this, the input is the total sum of blocks, and we are supposed to divide it into 3 towers. So first thing that you can do, and yeah, the task is to minimize the height of the maximum, the second tower basically. So goal is to make all 3 towers kind of equalish height, and so that the second tower is not quite high, because in n equal to, let's say, 20 case, you can easily make 2, 17 and 1, but that's not what we want. We want the height of tower to be uh, close values of each other, so that the second tower doesn't have large height, because in this case the difference is 15 here. So from this you should get a hint that first, let's try to, give all 3 of them n by 3. Just make equal blocks. Then decrease 1 from this and put it here. So now basically the second tower is the highest. Left one is 1 less, to be specific, n by 3 plus, and n by 3 minus 1. But now you will be left with some number of blocks, right? And that will be n minus 3 times n by 3. N by 3 is integer division, so basically n mod 3. And we can just easily check the cases. If n mod 3 is 0, then we are done. Basically n by 3 plus n by 3 and n by 3 minus 1 works. If it is 1, then we have one extra block, and that we can just put on second tower. If we put on left tower, then this both will be equal. If we put here, then this both will be equal. So we have no choice but to put on second tower. So this will be n by 3 plus 2. And if it is equal to 2, then we have 2 blocks. So again, in this case, the only choice is to put first block in second tower and second block in the left tower. So this will be n by 3 plus 2, n by 3 plus 1, and n by 3 minus 1. So this is the solution. The code will be quite simple. So I've given tower heights x, y, z, and x is the first, the highest tower, y is the second highest, z is the third highest. So initially n by 3, n by 3, n by 3. Then increasing x by 1, decreasing z by 1, and figuring out how many blocks are left. If 2 are left, I'll increase both y and x. If 1 is left, then I'll increase just x, and then just see out y, x, z. So this wasn't very hard. You can just greedily make all 3 of them as equal size as possible to minimize the height of the second tower. Yeah. So let's get into the second problem now. The second problem is array decrement, and the question here is that we are given 2 arrays, A and B. So let me just draw the array. So we are given 2 arrays, A and another array B. There is one type of operation that we can do on array, which is decrease all AI by 1. So all AI will become AI minus 1, but there is a catch that it doesn't go less than 0. So all AI greater than 0 uh, has this operation applied, and if anyone is 0, then it stays 0. So it will stay 0 in the end. And we are supposed to figure out if you can make array A into array B or not. So if you just think about it, if there is some element 1 here and the corresponding A element is 4, then means that this operation was done 3 times, right? To make 4 to 1. You have to do exactly 3 times, no less, no more. So if there is 2 in B, then A must be 5. If A is not 5 and something else, then this both contradict and we can't make this array. So we just have to, loop through array A and B, and if any of bi is greater than 0, then just check that this difference in both of them is same. If it's same, then fine, you can do this times this operation and it worked. But if it is 0, then we have to check one more thing. If it's 0, then in this case, if I put 1 here, then fine, I'll do operation once and this will become 0, and then next to operation it won't change. If it is 2, then fine, 1 0 0. Even 3 is fine, but if for example it was 5 here, then first operation it will become 4, then 3, then 2. So it won't be equal to 0, because the difference between 0 and 5 is 5, but we are doing this operation only 3 times, not 5 times. So whenever it is 0, you just store what is the maximum here, and in the end, if this turns out to be less than this, then it's fine. If it is greater, then we can't do this. So that's just the logical part, that all the difference should be same except in zero's case, which is kind of a corner case. So the code will be quite simple here as well. And so I'm just taking the input array A and B first. Then I'm just initializing difference, which is, this difference variable. Initially, I'm giving it a random value, which I know for sure will never happen. 118 will never happen. And then I'm looping through arrays. If b of I is greater than 0, then if difference is uninitialized, basically I initialize it to a of I minus b of I. And if difference is initialized already, but it is not equal to a of I minus b of I, then I just no and return. So basically it will print no. But if a b of I is already 0, then I store max to be max of the current value comma a of I. So it will basically store the max value at which is needed to make this a of I into 0. And afterwards, if difference is equal to 118, which means that all bi were 0. And if all bi were 0, means yeah, we can do that. Whatever is the maximum, just do that many times and everything will become 0. And if difference is greater than equal to maximum, which means that the max element is not 5, it's either 0, 1, 2, or 3, then like we can make it 0 in this operation, then we print yes, else you print no. One thing to note here is I'm initializing max to 0. So for example, if b was 5, a was 4, this was 6, this was 5, then in this case, yeah, difference is same in both of them, it's plus 1. But the thing is we can't do plus 1. So yeah, so I'm checking here if difference is greater than equal to max and max is initialized at 0. So in this case, the difference will be 4 minus 5 or 5 minus 6 is equal to minus 1. So diff variable is currently minus 1, and any negative thing will obviously be less than equal to max, less than max. So here, whenever there is decrement, it will, whenever there is increment, it will anyway take care of here. If you didn't do this, then you'll have to take care it separately, that if it's increment, then do something else. But I just took care of it in max variable. So I hope this was clear. Like both of them were a nice problem that you just think for some time, then you'll get the logic. And anyway, it's division 3, so that is expected. So now let's get into problem C. So C problem is restoring the duration of task. And yeah, the statement, I found it a bit complicated. It took me some time to understand what they really want. So I'll just explain it here. Basically, the guy is doing some tasks and we are given the starting and ending time of the task. So yeah, he'll start some task as I and he'll finish it at Fi. And what he's doing is maintaining a queue such that if there is some other task as I plus 1 coming in between, then he'll just push it in a queue. And if let's say a psi plus 2 is also in between, then yeah, he's just pushing it in at the back of the queue. And As soon as fi is finished, he'll just take the top task from here and start executing it and finish it at fi plus 1. And the duration of task is basically if at time ti he's starting this task, doesn't matter that starting time is actually si plus 1, he'll basically start doing at ti. Whenever he finishes the ith task, he'll start doing this task and he'll finish at fi plus 1. So duration will be fi plus 1 minus ti in this case. And we just want to figure out this for all of them. So let me take an example because this is a bit complicated. So yeah, for first one they have given here. So first task will come at 0 and he'll start, finish at 2, then he'll do nothing in 2 to 3, and at 3 he'll get second task, finish at 10, and then third task he'll finish at 11. And one example where there is overlap. So in this example, the second task he'll start at 16 and the task will complete at 199, but in between the 90 and 195 task will come. So he'll just push them in queue and store that I have to do the 90 task and 195 task. And when he'll complete the second task at 199, he'll start doing the 90 task. But 90 task is finishing at 200. So it will just take, duration will be just 1 because it will finish at 200 and he started at 199. So that basically is the duration. And the logic here is what the main goal is to find this ti. So when will he start the task? So first thing you can say it must be greater than si plus 1 basically, because I'm doing this for si plus 1. So ti must be greater than si plus 1 or equal to, because if task didn't come then it couldn't start. But one more thing, it depends on the finishing time of previous task, because he can start only after previous task is finished. So in this case it was 199 because the previous task got finished at 199. And the thing that they've given is both arrays are sorted and fi will be greater than si for sure. So basically you can just directly check for ti which is the maximum value of fi minus 1 and the current value of starting. So whichever is the maximum, at that moment he'll start. And the proof for it, you can say, because it is doing in queue. Because it is in queue, only he will start next task if previous task is completed. So the current task's ti just depends on previous task and current task. So we don't need to check anything else. We can just say that 13 and 16 max is 16. So we'll start at 16, finish at 199. In this case, this task would have come in between, but it doesn't matter because he's finishing at 199. So he'll start doing this task at 199, finish it at 200. Then in this case, the task had already come at 195, but he'll start only after finishing this. So he'll start at 200, he'll end at 260. After which there is a long pause from 260 to 1456, and after that at 1456 he'll start doing this task and end at 9100. So for each index I, you just check which one of these two is maximum, and whichever is maximum, that would be the actual starting time of that task. So the code is again quite small. Just take both input and initial answer will be f of 0 minus s of 0 because there is no task left of it. And after that, for all index 1 to n, it's just f of I minus maximum of s of I comma f of I minus 1, the starting time of current task and the ending time of previous task, because that are the determining factor of actual start time when I'm starting to do that task. And I'll finish at f of I. So this was it for the third problem. Now I'll move on to fourth problem. Yeah, fourth one is black and white stripe. Statement is quite simple, that we are given a string and which some characters are b and some characters are w, and we are supposed to find how many w at minimum you have to change to make a continuous segment of k blacks, k b's. So For example, in the second test case, it's B, B, W, B, W, and we want to make 5 Bs. So you have to change this to W into B and it will work. So the uh, way to solve this is, implementation, and like that implementation, just try to remember it. It will be used in many other problems. It's uh, basically moving a window of some specific length over the array. So what I mean by that is, if our k is, let's say, 4, this is my string, and let's say k value is 4. So what I'll do is, my plan is to check all the substring of length 4 and see how many changes do I have to make all of them black. So for that, I can just maintain current number of W and current number of B in my string at a point, and then the answer is just the current number of W, because if I change this W's into B, then I'll have k equal to 4 B's in a continuous substring. And the nice thing is, when I move from this range to this range, only one thing is getting out and one thing is coming in. So I can keep track of W and B continuously. If this was W, then subtract W, and if this was black, then subtract black, and when the next thing comes, if it's black, then add black, if it's W, then add W. So I'll again get new W and B value for this range, which is just one next of this previous range. And again, I'll check in this how many do I have to change, which is exactly W. So you can just move over the array, move this range over the array, and get the value of how many do you have to change for each subsegment of length k. And finally, just take the minimum of them all, and that will be the answer, because we have basically checked all the subsegment of length k which can be continuous b's, and obviously one of them is the minimum one, and so we just take the minimum of this. So this concept will be used in many other problems as well, where you'll have to move this window over the array, like one element will go and one element will come in. So try to keep this in mind. So logic is just this, and then it's just implementation. So first I'll make W and B 0, and initially I'll just take the first k elements, and for them, if it's B, I'll add into black, else I'll add into white, and after that I'm initializing answer as W because it is answer of first subsegment of length k, and then I'll move on from I equal to k to I less than n, and each time I'll check if current one is black, so the one that I'm adding. If it is black, I'll increase black, else I'll increase white, and I'll check the one that is going out right now, which will be I minus k. So I minus k is going out right now, and if the element that is going out of range is black, then I'll subtract black, else I'll subtract white. And after that, I'll just assign answer to be minimum of answer comma current value of W, and then in the end it's just printing answer. So yeah, if you have seen some similar problem previously, then you should have got an idea about how to do this, and if not, then just keep in mind in next problems. So let's move on to next one now. Yeah, so this is the fifth problem, the price maximization, and here the question is, basically we are given an array A and we want to make pairs of two elements, so total n by 2 pairs, and the value of each pair is defined as sum of weights of both elements in the pair divided by k and taking the floor, so basically integer division, and our goal is to maximize the sum of all the values in the pair. For example, then in the case of 327148, what we can do is make 7 and 8 as a pair, 3 and 4 as a pair, 2 and 1 as a pair, and we'll get 5, 2 and 1 balls respectively, so that will be total 8, and this is optimal for this test case. So that is what basically our goal is. So what I'll do in this case is, one fact that makes our calculation simpler is that if in A of I it is written as q times k plus r, where r is the remainder, then q is for sure added, right? No matter for which is the other partner in the pair of A of I, doesn't matter whatever is A of j, q part will obviously be added. So at first you can simplify while iterating through the array, just add A of I by k in the answer and just keep track of all the reminders afterwards, because only reminders matter. So for this I just made an frequency array count, which in which case count of I stores the count where reminder is equal to I, basically the number of elements in the array where reminder is I. So after which I basically have a count array which has value from 0 to k minus 1, and it stores the number of elements where the remainder is 0, k minus 1, and dot 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 so on. So now we have a challenge. How do we pair this element so that we get the maximum value possible? So see this, the count, the number of values which are 0 is actually useless, because 0 doesn't help anyway. Anyway, even if you pair it with someone, the reminders won't add up because 0 is 0, so 0 is useless. What about 1? 1 is actually useful when we have some element with reminder k minus 1. So in this case, I think we had, so yeah, we had 7 and 8. 8 has reminder 2 in case of 3, and 7 has reminder 1. So when you pair them up, you are actually getting 1 extra. So 7 by 2, 7 by 3 plus 8 by 3 is actually 4 only, plus 7 and 7, and 7 plus 8 by 3 is 5. So pairing this two is kind of giving us one extra marble, one extra burr than keeping them separated. So basically that's what we are trying to do. Pair k minus 1 with 1. So the number of count, for example, here is 3 and here is 4. Then you will pair up all 3 1 of this and 3 of k minus 1 together, and you will get 3 balls from this. And like the process is simplified because you don't even have to keep track of AI AJ. In this case, like if you want to really know what is happening behind the back, so if this was AI and this was AJ, then we are making a pair of AI plus AJ, where it is simplifying into AI by K plus AJ by K plus AI mod K plus AJ mod K by K. You basically get the idea. So this is basically happening, and we have taken care of all these terms. Now we are just taking care of AI mod K plus AJ mod K term. If you can get it to be greater than equal to K, then we are very happy we got one extra ball. So the way to do this would be two pointer, like you can get the feeling of it as well, because k minus 1 can pair up with 1 2 3 so on, k minus 2 can pair up with 2 3 so on. So you basically set L to be 1, R to be k minus 1, pair up both of this as much as you can. So basically whichever count is minimum, that will get exhausted. So if k minus 1 is exhausted, you move R to k minus 2. And now this is an interesting case. In k minus 2, we have some ones here. So will this once ever be useful? Can you pair this once with someone and get one extra ball? No, right? One can only get paired up with k minus 1, which is now exhausted. So all these ones are actually useless. So uh, for even if you have 10 elements with mod k equal to 1, now all of them, doesn't matter if they pair with anyone, they are not giving you extra ball. Whatever ball they could have given, they have already given in AI by k. So you just increase L as well to here. So L will be here, and if for example k goes to k minus 3, then L must be at least 3. So we need to keep on increasing L until it reaches k minus R basically. And when it reaches, make the pair of both element, which will be, the minimum number of occurrences of any of them, and then those pairs will give you extra balls, and after which, if L is exhausted, increase L, if R is exhausted, decrease R. So this is basically the two pointer solution of this, and it's kind of like greedy approach because you can, actually make pairs and prove that this is the maximum pairing because you are using the higher reminder balls as optimally as possible, pairing them with 1, then pairing them with 2, then 3, and so on. So the code is again not very big, so I'll just open this. Yeah, it's opening. Okay, yeah. So first I'll just take the input. I'm declaring the count array here and answer here as well. I'm adding AI by k to the answer because anyway I'm getting that, and this just increasing the count of AI mod k. So dividing them into mod k buckets and storing how many are there in each one. And then the two pointer part starting at k minus 1 and L at 0. If count of R is 0, which basically means that I've exhausted the R1, then I'll decrease R and continue. If count of L is 0 or R plus L is less than k, so it's like this case when I was at k minus 2 and this 1 was still there. If 1 is there, then 1 is basically not at all useful, so I'll just skip 1. So that is covered by here L plus plus. So even if it is empty or I can't make k, I'll just skip L, I'll continue. If at some point this process leads to a case where L is equal to R, then I have to not just do this normal process, I have to take care that the pairing will happen in between. So total count of L by 2 pairs only I can make. I can't make uh, like the normal process that I'm doing when L and R are distinct. Basically taking the minimum of L and R and increasing it into answer, subtracting it in both of them. So this won't work when L is equal to R, kind of like a corner case. So here I'll just take count of L by 2 and I'll break out because I know that after this either L will decrease and R will decrease. So this condition is anyway not going to hold. So I'll just break out from this. So this is the solution, and like after getting the logic, the coding is not very hard if you know how to code usual two pointers. So I hope this was clear. I'll now move on to the sixth problem, which is shifting string. So this is also a very interesting problem. I'll explain the problem with an example only. I think that would be easier for you to understand. So I'll just make a box here, paste whatever I copied. I don't need link, and the size, let me increase it to 36. Yeah. So they are basically giving us a string and an permutation array, and they are doing one specific process on the string. And the process is they will convert this first letter to be whatever index is written here. So if 3 is here, they'll change the first letter to be third letter, second letter to be fourth letter, third letter to be fifth letter, fourth letter to be second letter, and fifth letter to be first letter. So if you do this, then the string becomes A B A B A. It actually remains same in this case. Let me just take all of them in different so that you can understand. So A B C D E. In this case, first character will become the third character. So C and D, then E. Then the second one is B, then the last one is A. So C, D, E, B, A. This is the transformation of the string. They are using the word multiplying, I guess, if I remember correctly. So yeah, multiplying S by P will do this process, which I explained. and our goal is to find the minimum number of iteration such that the initial string is repeated by repeatedly multiplying this. So if I multiply by this string again, the 3 4 5 2 1, so it will become E B A 3 4 5, then 2, so D, then C. If I do multiplication again, then it will be A D C B E. Multiplication again would be C B E D A. Again multiplying will result in E D A B C. Another multiplication will give A B C D. So yeah, so after 1 2 3 4 5 6 multiplication, I am getting my string back. So our goal is to figure out this, and one thing from this example itself, if you might have noticed, is that look at the position of B and D. They're actually cycling. B is coming to this, D is coming to this, and not just this, look at ACE. AC itself is also cycling. C will go here, E will come back here. And like this is not a coincidence, this will happen always because of the condition that we're given, because of the way that we are transforming. So transformation, first character is going to third character, but third character, which is basically this, is actually going to fifth character, and fifth character, which is basically this, is transforming to first character again. So this is basically creating a cycle of three numbers. So in each multiplication, the string will transform in such a way that the first character will go at third position will go at fifth position will come back at first position. And similarly, if you see second character is going to fourth character, and the fourth character is coming back to second character. So in whatever permutation we are given, there will be some set of these cycles that are cyclically shifting the characters of the string, and we are not really sure what all the cycles are. So first goal will be to figure out what these cycles are, and after which, if you can see, this cycle is of length 3, this cycle is of length 2. So like common sense says that just take the LCM of this and you'll get the answer, which would be 6. In this case it works out, but I can just simply give you counter example A B A D A. In this case answer will be just 2, because this is a cycle of 3, but it turns out all the characters are itself same, so it kind of reduces into cycle of 1. It doesn't it isn't really cycle of 3, it will stay same in even in cycle of 1. So like my goal to solve this problem would be first figure out all the cycles that are there, then the cycles will be, let's say, a string s1 s2 s3. So s1 will consist of character at position 1, then character at position 3, then character at position 5, because these are the strings that are cyclically shifting. And then if I can figure out the minimum iteration, for example let's say x, where after cyclically shifting s1 continuously, s1 becomes s1 again, then I'll get the period of this transformation. So after applying this transformation x times, at least this positions will again reach the same position, same as initial position. After applying 2x again, all this 1 3 5 will reach same positions. If I can figure out x, then I can do this. So for this, I was actually trying to get this in O of n, so it was taking time, but then I realized that constraint is that n is capped at 200. So you can actually do this in O of n square, which is basically just checking all the possible things, all the possible cyclic shift. So if the length is n, then there are total n cyclic shifts. So 1 2 3 to n will have 2 and 1 3 dot 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 1 2, all this. So there are totally n cyclic shifts, and you just keep on doing cyclic shift, checking if it is equal to initial string. Whenever it becomes equal to initial string, just store that this is the period of this specific string. And after you get period of all the cycles that are in part of this permutation, you can just take LCM of all of them, and that will be correct answer. Not just directly taking LCM of lengths, because characters can be repeated. So this is the full solution. It was kind of like properly constructing what you have to do. First, figure out that you have to separate all the cycles, then realize that each cycle is just shifting by one and n is limited, so I can just figure out what is the period of each cycle and then just take LCM of all those period. So for that, let me just explain you the code. So after learning all this, it just becomes a implementation problem. How do you implement it? So the way I have done is, first I made this function find rotation, which basically gives me what is the number of cyclic shifts, the cyclic rotations that I have to do to get back to initial string. So for that, I'll just make a temporary string t, and the first cycle will first shift I'll have to do is, so if the string is 1 2 3 to n, here we are actually going right side, so the next shift will become n 1 2 3 dot dot dot. So for this, the thing that you have to do is just take the last character of string and then take the substring of n minus 1 size from the first character. So this to n minus 1 will come here and n will come here. So this is rotation by 1, cyclic shift by 1, and answer is 1. I'll keep on doing this until t is not equal to str, and it will be str at least after the size of string cyclic shift. So there is no issue of this looping forever. And inside the loop, I'll again just increase answer and do next cyclic shift, which is again similar process as this. And in the end, just return the answer, which will be the minimum number of cyclic rotations that I have to do so that initial string is back. Basically, the period of rotation for this string. And yeah, I have written LCD. It's actually LCM, but during the contest solving fast, this thing happens. So underscore GCD is inbuilt GCD function, and this is just LCM. So first just take the input. This is all taking permutation. Yeah, so this I'm used to zero indexing. So for this, whenever a permutation question is there, I'll just subtract one from all element in the AI so that it becomes zero index. If you prefer one indexing, then you can just do everything in one index, but this is done so that it's zero indexed. And after which, the this is a vector of vector, which is actually storing all the cycles of the form like this. So it will store 1 3 5 and 2 4 in this case. 1 3 5 2 4, these are the two vectors that will be stored in the vector v, and figuring out them is just simple. Just follow the process. You are at 1, you state 1, see where it's going. 3, you go at 3, see where it's going. 5, and see where it's going. When you're back at 1, you found the cycle. So I'm just doing this process over and over. I'll just make a current variable as I, and I'll push it in a temporary vector as well. And while a of cur is not equal to I'll just keep on pushing a of cur in my vector and setting cur as a of cur. So just following through the process of transformation where it's leading me, and some point it will lead back to I for sure. So that's just it. And after which I'm pushing back, I'm storing all the indexes that I've covered in and set done, so that none of them is repeated, because I'm just directly iterating to an element. So while starting at 1, I'll already found a cycle that 1 3 5 are in cycle. So after next iteration, when I reach index number 3, I don't need to do anything because it is covered. I already found it in a cycle. So that's why I'm just checking if it's already done, then just continue. If not done, then find the new cycle. So and then just push back this vector into the vector which is storing all the cycles. And now this is a vector which is storing string of cycle, in which I'm just converting all the indexes in vector v to be the characters. So let's say there is a vector I in the cycles, then I'll go through each of the elements. So the elements will be 1 3 and 5, and I'll just see which character is at element 1. Which character is at element 1, I'll just take that element, and at 3 I'll just take that element, and at 5 I'll just take that element. So I'll just convert 135 into AC, basically transforming from indexes to string. That is what I'm doing into this part. And after which the cy stores all the cycles of the string that are cyclically shifting each time. So basically rotation, Caesar cipher, Caesar rotation of 1 each time. That's what not the Caesar rotation, the cyclic rotation of 1. So I'll just initialize answer to be 1, and then it's just simple. I'll just take LCM, read at LCM here, LCM of current answer, and find rotation of the string in CY. So yeah, this was actually not quite long, but a problem where you have to make a construction step by step. You figure out that there are cycles first, which are actually shifting just one position to the right. So some characters which are going just one position to the right each time. So you'll get the structure of cycles, and then if you figure out what is the period of each cycle, then you can just take LCM of all of them. So this was it for the first 6 problem. If you have any questions, then do put in comments. Thank you.
Hello guys, I'm Aditya, head of the programming club, and let's look at the solution to the last problem, count the trains. There are n independent carriages in the rails, numbered from 1 to n. The carriages are not connected to each other and they're moving to the left. So you have carriage 1, then carriage 2, then carriage 3 and so on. The ith carriage has its own engine which can accelerate the carriage to AI km per hour, but the carriage cannot go faster than the one in front of it. So maybe we have say carriage like 10 and 13. So if we have two carriages like this, then both carriages will have to move at 10 km per hour to the left because this can't go faster than the one in front of it. So there are also messages saying that some engine has been corrupted. Message KD means the speed of the kth carriage has been decreased by D. Messages arrive sequentially. The processing of the next message takes into account the changes from all previous messages. After each message, determine the number of formed trains. So you can understand the problem statement with the given example statements. So once you understood the problem, let's go to the solution. My solution to this problem is based on the idea of square root decomposition. So what I'll do is, let's say we have n carriages. So I will divide the n carriages. So let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 carriages. So I'll divide the n carriages into square root chunks of size square root n. So let's say we had 11 carriages. So in this case, I'll divide into chunks of size root 11, which is going to be, I'll just take floor. So let's see, we'll have chunk 1, chunk 2, chunk 3, and chunk 4. So each chunk will be of size floor of square root n. So we'll have like root n, or like maybe root n plus 1 or root n plus 2 chunks, right? It'll be order of root n chunks, the number of chunks that I have. So now once I have chunks like this, what I'm going to do is, for each chunk, I'm going to store the speed of the frontmost train of the chunk and the backmost train of the chunk. So f0, b0, f1, b1, f2, b2, and f3, b3, right? So for each chunk, I will store fi and bi, where fi denotes the speed of the first train in the chunk, and bi denotes speed of the back train in the chunk, right? Front train and back train. So the size of the array f, or the vector f, will be square root n. order of square root n, like something slightly more than square root n, and similarly for b, right? So after defining these two, I'm going to define one more thing. I'm going to define another vector array siz. So what siz will store is the number of trains in chunk I. Number of trains in chunk I. So this is chunk 0, chunk 1, chunk 2, chunk 3. So in this chunk, I'll try to find the number of trains, in this the number of trains, in this number of trains, and in this number of trains. So note that you can have a train like this, right? Maybe these 4 carriages all have the same speed and they can form a train. So I'll be counting it once in this chunk and I'll be counting it once in this chunk, right? So hopefully that clears up the confusion. If like what if there's a train that spans different chunks. So I'll be counting it once in every chunk that it occurs. So now this is the initial setup. So initial setup of 3 arrays. So f, b, and siz. All of them have size square root, right? And f denotes front train, b back train speed, and siz denotes number of chunks. So if you see my solution code, so initially I'm declaring a vector of a, to denote the max speeds that each carriage can go to. I'm defining t to be square root n, and after that I'm creating vectors f, b, c of n, and size. So I'll tell what c of n is. So a of n, a of I will give you the max speed of carriage I. C of n will give you the current speed of carriage I. For example, in this case of 10, 13, 5, 2, 6, we know that the second carriage can't go with speed 13, so it goes with speed 10. So a of 1 will be 13, but c of 1, the current speed of carriage I, the current speed of carriage 1 will be 10. So c of I will store 10. So now for the initial given setup, computing c of I is simple. So c of I will be either limited by the carriage speed or limited by the carriage in front of it. So c of I will be min of a of I comma c of I minus 1. That will be for this. After that, I need to set up the front and back speeds. So I have found the chunk size to be square root n. So I just go in chunks of square root n and I push back the frontmost train in the chunk speed and the back train in the chunk speed. So f dot pushback of c of I and p dot pushback of either it be I plus t minus 1 or limited by the total number of carriages, min and minus 1 I plus t minus 1. So this will be for setting front and back speeds. Now, after setting front and back speeds, I want to find the array size, right? The number of trains in each chunk. So, to find the number of trains in each chunk, I've written a small function over here. So, find siz, given the vector c, the current speeds, and given from where I want to find the number of chunks. Basically, I'm giving the starting point of the chunk, and we know that the chunk is of size t. T is a global variable, so it can access anywhere. So from start to start plus t minus 1, I want to find the number of trains that are present. So for that, I start from strt plus 1 and the number of compartments I initialize to 1. While I'm within my given range, if the next train has a speed lesser than if the current train has a speed less than the previous train, then that will mean it is the beginning of a new train. So I increase this cmp plus plus, the number of compartments plus plus, and then I go to the next train. So this is a straightforward code. I'm basically finding the number of places where the speed changes, and wherever speed changes, that will be the beginning of a new chunk. Sorry, that will be the beginning of a new train. So maybe you could have a setup like this. So in this case, for this chunk, the number of trains will be 3, because initially this will be in train 1, this will be in train 2, this will be in train 3. You will have 2 points where the speed changes. So answer will be 1 plus 2, which will be 3. So I'll return the compartment size and I'll store that in the vector size. So this is the initial setup. Now let's talk about how we can deal with queries. Right, so let's assume we've done this initial setup of f, b, and size. Let us say the speed of this train changes. Now note that this train does not affect any train or any carriage in front of it. This carriage speed does not affect any of the carriages in front of it. So we don't need to do anything to that. Now, what can happen when I change the speed of this train? It's possible that because of this, maybe it was traveling at a high speed 10 and its neighbor is only at a speed of 5. It could be that this speed goes down to say 4. If it goes down to 4, all of the trains behind it will have to slow down. So that is a possibility, and you could have a new carriage being formed, sorry, a new train being formed over here. Or it's also possible that, like, maybe these two trains, they were part of the these two carriages were part of the same train. Maybe they all traveled with 10, but then this capacity reduced to 5. So now this becomes a new train, right? So this is the possibility. Note that the number of trains in this chunk will only get affected, right? For this, like, there'll be effect over here as well, but there'll be no effect on the chunks that come in front of it. So let's work on this chunk alone and try to find what is the change in this chunk. So the reason why I'm maintaining F and B is, say speed changes here. So let's say all the trains initially had a capacity speed of 10, right? And then I change the speed of this train to 5. I can't go and change the speed of all the trains that come over here. That would take me O of n time. So instead, what I will do is I will just change front and back for each of these chunks. So because there are only order of square root and fronts and backs, that will only take us O of square root n time. And I won't change the C values. I won't change the current speed for all chunks. I will only change it for the chunk where we had a train that malfunctioned, like where we had a carriage that malfunctioned. For the chunks that come after it, I won't be changing the individual values. When I will change the individual values is when there's a corruption that happens in that chunk. So as I'm updating f and b values regularly, I can use the f and b values to update the c values. So what I'm doing is, say I get a query, I'm getting the index and the speed change, and I'm changing the capacity of the engine accordingly. Now what I'm doing is, I am modifying the current speed of that train. So if this train was modified, I am modifying the speed of that carriage. So CFII current speed will be minimum of whatever current speed it had before, or the reduced capacity. So now this can lead to changes later as well. This will lead to changes in the speeds of the carriages later. So for that, I have written a function update int. So what update int will do is, it will update the speeds of all trains that are present within this chunk. So what update int does is, it takes a start point of the chunk and the current speeds, and it goes through the whole chunk. And what it does is, for valid indices, it will do current speed will be equal to min of current speed of previous train, comma current speed of this train. And I am also updating front value, if you see it. So the in will be the starting index of the chunk. I am doing C of in is min of C of in, comma front of this interval or this chunk. I'm calling it chunk or interval. So I'm changing the f value for this chunk, right? So I'll have to take into account that as well when I change the speed of this carriage. So speed of this carriage will be minimum of whatever I had assigned before, which could have been changed later, and that change will be affected in f. So whenever a change happens in this chunk, I will change the f and b values of all chunks that come after it. So whenever I want to change the speed of some particular carriage in that chunk, I'll have to look at the f and b values as well. So I'm looking at the f value. So c will be modified if f is modified, c also gets modified. And once the starting carriage speed is modified, like a domino effect, that will change all speeds in this chunk. And that will be taken care of this update function. So now with that, I will get the correct speeds of all carriages present in this chunk. And once I have the correct speeds, I can always run my find size function to find the number of trains that are present in this chunk. So what I'm doing is, first I'm updating, ensuring the A update is taken care of. Then I am ensuring whatever F update that happened is reflected in the whole chunk. After that, I'm updating the whole chunk. After updating the whole chunk, I am updating the number of trains present in the chunk by doing this. Now, after the trains are updated, so it's possible that, like, maybe I change the speed of this train. So initially, say maybe f was 5, but then because of engine corruption, a became equal to 2 for this. Note that I updated all the c values over here. How did I do that? I did using this and using update int. That will update all c values, but the front value of this interval may not get updated. So I am updating that as well. F of intr will be the current speed of the first carriage in the interval. And similarly, I am updating the back value because I updated all carriage speeds over here. So using that, I'm updating front and back values. Now once I'm done with that, like for example, if say all of these carriages had speed 5 before and A became 2 over here, so all of these will also have their F and B changed, right? So I'm changing F and B's for those. So front of A will be whatever existing value it had or the back value of this carriage. So this carriage back value may have changed. So based on that, I am changing the front value for this carriage. So f of I, so where I is starting from the next chunk, uh, INTR is the chunk where the modification happened. I'm going from the chunk after the modification to the end of chunks, and SE is just f dot size. So I'm modifying f of I. Either it could be the same value it is before, or it will be limited by the train in front of it. And B of I will be limited by the changed f value or the old B value, right? With this, I'm updating f of I and B of I. Now, if f of I and b of I turn out to be equal, if the front carriage speed and the back carriage speed turn out to be equal, then all of them should have the same speed, which means all of them belong to the same train. So I change size to 1. Else, what I'm doing is, else maybe only the front value changed and the back value didn't change. So there could be an update in the number of trains present over here. So how can that happen? So maybe before f was equal to say 5, and then you had speeds as 5, 4, 3 in this, and b was equal to 3. Now maybe a became say 4. Because of that, this back value will become 4, and because of that, this front value will become 4, but this back value will remain 3. So you will have a chunk of 443. You'll have a train of 443. So the number of trains over here is changing. So I will have to update that, right? So for that, what I am doing is I am setting a bool variable c is equal to true. So that will be like the first carriage, the first chunk that I'm changing. So in the previous chunks, I'm like if f and b turn out to be the same, all the carriages will have the same speed. So I don't want to go and change that because that will take me off square root and time, and that's waste of time for me because I can directly find the number of trains. But in this case where you had a 443, I may not be able to directly find. So I am changing all the carriage values as well. How am I doing the change? I am first changing this train speed, the front train speed, CFAB equal to min of CAB f of I, and then I am updating all carriages present in this chunk using my updated function, and this will take O of square root n time. And once I'm done with the update, all the carriage values in this chunk will be updated. So I've updated 2 chunks now, so O of 2 root n, and after that I'll use the find size function again to find the number of trains present in this carriage. Now note that after this carriage where the front value changed but the back value didn't change, because the back value didn't change, none of the carriages later will also change speeds. So if the back value does not change, there won't be a change in the speeds of the carriages that come after. So I don't need to go and change the number of trains in these carriages. So I'll just not do any change. So because of that, this loop will run O of root n times, and in that once I will find a carriage where the front changes but the back does not change, and for that carriage alone what I will do is I will go through the whole carriage. So it will be O of root n plus O of root n, no, O of root n time, and again I'm doing a couple of O of root n's over here. So for one query I am taking O of root n time so far, and so far I have found the number of trains in each chunk. Now I want to find the total number of trains, right? So for that what I do is I'll just add the number of trains in each chunk. But if two chunks, you have two chunks like this, such that the speed of the last train over here and the speed of the first train over here are the same, then there's a common train in both of them, and that will get double counted, right? If I just add size of this plus size of this. So to avoid the double counting, I'll do answer minus minus. So just add all the sizes, but if in the boundary there's the same speed, I'll just do answer minus minus, and that will give me the total number of trains present in all the n chunks, counting only distinct trains, and then I'll just output that. So again, this will again be O of root n because I'm just going through each chunk, and you have order of root n chunks, and thus each query will be managed in square root n time. So time complexity of the code will be m root n, which is pretty sufficient to pass the time complexity. So giving an overview of the whole code, what I'm doing is I'm first setting up by declaring 3 vectors f, b, and siz, and dividing the whole the train thing, the n trains, into square root n chunks, with each chunk being square root n size. And then I'm initially finding the current speeds of all trains, finding the front train speed and the back train speed in each chunk, and finding the number of trains in each chunk. Now, when I get a query or when I get a modification, what I'm doing is I'm only modifying the front and back for all chunks. That will take me overflow time, and that is done by this. And I am modifying the internal values, meaning the speed of all the carriages in a chunk. I'm doing it only for a couple of chunks. One is the chunk where the train itself got updated. For that I have to change because the number of trains in that chunk will change. So for that I have to update all C values, and I also have to find the number of trains in the chunk. And also in a chunk where the front value changes but the back value doesn't change. If front value changes and back value doesn't change, that means the number of trains in that will change. If both front and back change, then both will become equal. So if both become equal, I don't need to find the number of trains by doing any computation. The number of trains will be 1. So only for the case where front changes but back doesn't change, or like, and they both are not equal, only for that case I need to go through the chunk fully. So I'm updating the C values only for that chunk. Note that F values and B values will always give you correct speeds, but the C values won't give correct speeds. But whenever I go into a carriage and do changes there, I will take into account the F and B values so that the carriage's correct speeds are updated. This way, by changing only F and B's, I just do O of root and changes in each query, and I can maintain a time complexity of M root. And this is my solution to the problem G. If you have any doubts, please feel free to put in the comments, and if you like the solutions, please make sure to like the video and share and subscribe to the channel. Thank you.